Okay, we have a problem here. We have a table. It gives selected values of the twice differentiable functions f and g, as well as the first two derivatives of g. F prime of x is 3 for all values of x. What is the value of the integral from 2 to 4 of f of x g double prime? All right, well, I see a product here, and if you have to do a definite integral and it's a product, very possibly you need to use integration by parts, which is what, you can tell the title here. So remember, integration by parts says that if you have an integral that you're thinking of as something times the derivative of something else, that's equal to uv minus the integral of v du, where you let your u be the thing whose derivative is manageable, derivative gets simpler, and dv something whose derivative is whose antiderivative is manageable. With notation like this, we're going to let dv be the g double prime because its antiderivative is just g prime, whereas the antiderivative of f involves the integral symbol, so we don't want that. So we're gonna try this formula by calling that u and that dv. Okay, and then we're integrating obviously from 2 to 4. Okay, so let's see. So this integral. All right, so the integral from 2 to 4 of f of x g double prime. And I'm kind of just hoping, I haven't even looked at this problem. I'm hoping everything falls into place, and I just kind of have faith that it's going to. All right, so I'm calling that u. I'm calling this dv. Okay, so let's see. We get u is equal to f of x, and dv is equal to g double prime dx. We take a derivative, so du is equal to f prime of x dx, and then we take an antiderivative, and that would just be g single prime. And then we apply our formula. So this is uv, so that's f of x times g prime of x. Okay, that's uv minus the integral. By the way, so once you've done part of an antiderivative, that's going to be evaluated from 2 to 4, so we'll come back to that. And then here it's minus the integral from 2 to 4 of the integral of v du. Okay, so the integral of v du would be f prime, okay, g prime, okay, so the thing, so I'm noticing well, this is a multiple choice. It's I should be done by now. We're close to being done. We got to look at our table, and this actually can get simpler because they did give us some info, which is that f prime is always equal to 3, right? So here, I'll move this out of the way for now because we're done with it. Okay, but now to evaluate this, so first, as the fundamental theorem says, this will be f of 4, g prime of 4, minus f of 2, g prime of 2. Okay, and then over here, so this integral here, I'm just going to replace this with a 3. So let's say it's minus 3, the integral from 2 to 4 of g prime. Okay, so we'll clean everything up and then go look at the table. Well, actually, why don't I look at the table first to get those values? The antiderivative of g prime is just g, so the table is going to eventually give us all our info. F of 4, according to our table, is 13, so this becomes 13. G prime of 4 is 7. F of 2 is 7. G prime of 2 is 1. Okay, and then this integral here is just going to be 3. So I'm going to put that over here, just off to the side. That integral there is going to be 3. And then by the fundamental theorem, an antiderivative of g prime is just g. So it's 3. And then evaluating from 2 to 4. Kind of using different symbols, sorry. Why don't I just Okay, so then that's 3 times g of 4 minus g of 2. Why don't we clean this up? So we're going to be minusing this value, what I get here. So g of 4 is 9, and g of 2 is 2. So this is 9 minus 2. So it's 3 times 9 minus 2, which is 21. So that's minus 21. So now with the arithmetic, I get, it's this 91 minus 7 minus 21. So that's 70 minus 7, so that's 61. Nope, 70 minus 7 is 63. And that's answer choice A.